Hello, welcome again. We are solving some conventional questions of thermodynamics. The topic is thermodynamic processes. Question number 69 from Civil Services Mains 2024 is a 2-gram quantity of air undergoes the following sequence of quasi-static processes in a piston cylinder arrangement. 1. An adiabatic expansion in which the volume doubles. 2. A constant pressure process in which the volume is reduced to its initial value. 3. A constant volume compression back to the initial state. The air is initially at 150 degrees Celsius and 5 atmosphere. Calculate net work on the air in the sequence of processes. So this is the so here the initial temperature is 150 degrees Celsius, initial pressure is 5 atmosphere and mass is 2 grams. So initial pressure P1 is 5 atmosphere, temperature T1 is 423 V Kelvin and mass is 2 by 1000 kilogram. So first process is your adiabatic expansion process in which volume doubles. So this is 1, 2. Okay. And second process is constant pressure process. So in which volume is returned to its initial value. So 2, 3 constant pressure process. Third process is constant volume process back to its initial state. So 3, 1 is your constant volume. So 1, 2 is adiabatic expansion. 2, 3 is constant pressure. 3, 1 is constant volume. So considering first process and applying state equation at 1 and 2, so P1 V1 by T1 is equal to P2 V2 by T2. As it is given that volume double, so V2 is 2 times of V1. So putting this V2 is equal to 2 V1. So we get P1 by P2 is equal to 2 T1 by T2. So this is equation number 1. As this process is adiabatic expansion process, so P2 by P1 is equal to T2 by T1, therefore gamma by gamma minus 1. So this is equation number 2. From 1 and 2 we have 2 T1 by T2, because T1 by T2 is this, and P2 by P1 is T2 by T1, so it will be T1 by T2, therefore gamma by gamma minus 1. Okay, from 1 and 2 we get this. So this T2 by T1 it comes here, then it will be T2 by T1 gamma by gamma minus 1 minus 1, because this T2 will come here, T1 will come here, and power will remain same, and this is also T1 by T2, so we will subtract minus 1 from this, and this 2 will come here. So it will be T2 by T1, therefore gamma by gamma minus 1 is equal to 1 by 2. Or because gamma for air is 1.4, so gamma by gamma minus 1 is 3.5. So putting this as 3.5, so we get T2 by T1 as 1 by 2 raised power 1 by 2.5, and T1 is 423 Kelvin, 423 Kelvin, and this is 0.5 raised power 1 by 2.5. So T2 is 320.57 Kelvin. Okay, so this is the temperature T2, and T1 is your 423. So as 1, 2 is your adiabatic expansion process, so in adiabatic expansion the work done is mR bracket T1 minus T2 divided by gamma minus 1. So m is 2 by 1000 and R is 287 and gamma is 1.4, T1 is 423 and T2 is 320.57. So work done by air is 146.987. Okay. So now second process is constant pressure process. So now applying state equation between 2 and 3 at point 2 and 3. So P2 V2 by T2 is equal to P3 V3 by T3. So as it is given that the volume reaches to its initial value, so it means here from the diagram we can see that V3 is equal to V1 and V1 is equal to and V2 is equal to 2 V3 or 2 V1. So V3 will be equal to V2 by 2. So putting here V3 is equal to V2 by 2, So V2 by T2 is equal to P2, this V3, V2 by 2 by T3. Okay, and P2, because it is constant pressure process, so P2 will be cancelled out by P3. So we get relation 2T3 is equal to T2, and T2 is known. So T2 is 320.57. So T3 is 160.285 Kelvin. Okay, so this is T3, and work done is NCP T3 minus T2. That is the formula for constant pressure process. Now we have T3, we have T2, and CP is 1.005 kilojoule. To convert kilojoule into joule, we will multiply 1000. So it is kilojoule per kilo, and mass is 2 by 1000 kg, and these temperatures are also known as T3 and T2. So it gives negative work done by air, that is minus 322.172 joule. So these are the two work done from two processes, and third process is constant volume process, so no work will be done on this. Okay, so W net is W12 plus W23 plus W31. So that is 146.987 minus 322.172 plus 0. So that is work done by air in the cylinder, and work done on air is negative of this. As it is negative, so it is positive. So answer is 175.181, because it has been asked that work done on air. Work done, calculate the work done on air, so it is positive. Because compression work is more, or you can say negative work is more, so negative work is work done on air, so that is more as compared to extension, so the work done on air is positive. So answer is 175.181 joule.